Ray-Ban style for just $2.99. These are all steps along the path to an embodied internet. But the ultimate goal here is true augmented reality glasses, and we've been working on that too. And today, I want to show you an experience that we've been working on for Project Nazare, which is the codename for our first full augmented reality glasses. Here, you'll see you're chatting with friends on WhatsApp and planning a game night. You can select a game, and then, as you walk over to your kitchen, you can easily just put your game onto the table and you're off. And that's the kind of experience that augmented reality will unlock. There's a lot of technical work to get this form factor and experience right. We have to fit hologram displays, projectors, batteries, radios, custom silicon chips, cameras, speakers, sensors to map the world around you, and more into glasses that are about 5 millimeters thick. So we still have a ways to go with Nazare, but we are making good progress. I'm excited about our future roadmap, but even that's still early in a journey that's going to go on for decades. Immersive all-day experiences will require a lot of novel technologies. And for the last 7 years, our research team has been working on a broad array of technologies that are necessary for these next-generation platforms. Michael Abrash leads this team, and he's going to join me to talk about some of the future technology that we're developing. Hey, Michael, do you want to take everyone through our roadmap?
Sure. That covers a lot of ground, though. It's going to take about a dozen major technological breakthroughs to get to the next generation metaverse, and we're working on all of them. Displays, audio, input, haptics, hand tracking, eye tracking, mixed reality, sensors, graphics, computer vision, avatars, perceptual science, AI, and more.
Yeah, you're right. That's a lot. We probably only have time for a couple right now. You want to pick a few?
Well, I think the metaverse is really going to be first and foremost about connecting people, so I'd say let's start with avatars.
Yeah, I agree. The goal here is to have both realistic and stylized avatars that create a deep feeling that we're present with people.
Exactly, and we've shown codec avatars before.
Well, what can your face do? Can you show us?
Well, I've always hoped you would ask me that question.
And it's a remarkable experience to see codec avatars in VR, and photorealistic avatars will be a huge breakthrough. But they're only part of the picture.
Yeah, because you're not always going to want to look exactly like yourself. That's why people shave their beards, dress up, style their hair, put on makeup, or get tattoos. And of course, you'll be able to do all of that and more in the metaverse.
So this next video shows how we're making progress on part of that with hair and skin rendering and relighting for 3D avatars.
She's going for a medical field. I think she was interested into...
Now, I want to point out this technology is still very definitely research, but it shows the really high level of fidelity that avatars are ultimately going to need to reach. Notice that you can see the individual pores on his skin. Now, clothing is another important way to express yourself. And whether you want to simulate your actual garments, say you're making a quick call with your grandmother, or maybe you just want to be wearing a stylish blue Oxford shirt like me, you're going to need the ability to simulate clothing. So here's an early look at hand-cloth interaction. And you can see how the movement of the cloth when the hand touches and stretches it is really remarkably accurate.
Now, to use your avatar to teleport to a meeting or sit down for a chat in the metaverse, you'll also need realistic virtual spaces to be with people in. So let's look at that. Contrary to how this looks, this is actually not a video of the physical world. It's a 3D reconstruction of a mock apartment, which I guess just became clear when that bowl took off by itself.
Exactly. So what you can see here is that a researcher is moving around various objects on the right, and then on the left you can see the high-fidelity real-time rendering of the space in the moving objects on the left without the researcher. So what's critical here is that this is all happening in real time. That's what's novel here, and that's what differentiates it from CGI. So what we've seen so far is pretty awesome, but we all know what we want. We want the whole package, a full-body avatar in a virtual environment, so you're just there. Last year, we showed our very first full-body codec avatar at Connect. Here to tell you more about our progress since then is Yasser Sheikh.
Hi there. My name is Yasser, and I direct the Facebook Reality Research Lab in Pittsburgh. Well, that's not completely true. What you're seeing is actually a rendering of my pre-recorded codec avatar. Over the past couple of years, we've made quite a bit of progress with codec avatars. My avatar can now look left, look right, look up, look down, make facial expressions.
Here, you can see Elaine is in VR on the right. You can see her view of Yasser's avatar and the reconstructed real-world space that it's in on the left as she moves around the avatar. What you see on the left is an entirely virtual reconstruction. This gives you a sense of a future in which you'll be able to interact with another person's realistic avatar in virtual reality in real time. Now, preventing others from using your avatar will be critical. That's why, even though this is early-stage research, we're already thinking about how we could secure your avatar, whether by tying it to an authenticated account or by verifying identity in some other way.
All right, so we've talked about what we're going to be able to see, but of course we also want to be able to actually do things in the metaverse. And while seeing your hands in VR and manipulating virtual objects is a big step forward towards that, then we're going to need an even easier and more intuitive way to interact with virtual content when you're on the go wearing AR glasses. And we believe that neural interfaces are going to be an important part of how we interact with AR glasses. And more specifically, EMG input from the muscles on your wrist combined with contextualized AI. It turns out that we all have unused neuromotor pathways, and with simple and perhaps even imperceptible gestures, sensors will one day be able to translate those neuromotor signals into digital commands that enable you to control your devices. It's pretty wild. So let's take a look at what EMG input is going to be able to do and where we are with it today.
This video shows some of the ways that we think that wrist-based neural interfaces can provide an important input tool for AR glasses. So at first, that input is going to just be around enabling basic gestures, click, scroll, select. But as the technology evolves, EMG input could potentially unlock full-speed typing, and it could give you subtle, personalized controls that you can use in any situation. This is genuinely unprecedented technology. So let's look at an early prototype that shows how it could be used in AR. This experimental UI shows for the first time how EMG input could one day allow you to send a message in AR with your hand resting comfortably at your side without ever having to look at a screen. Notice how the researcher used an overt and highly visible click gesture to send the first message. We've made a lot of progress over the last year, and we're now able to do the same thing with the smallest of movements of the hand. EMG enables this by picking up subtle neuromotor commands with remarkable precision.
So basically what you're saying is that you're going to be able to send a text message just by thinking about moving your fingers. That's going to be pretty amazing. But I guess it's just one part of the equation, because the other is AI that understands your context and can give you a simple set of choices based on that context. So let's take a look at an AI interaction model that we've built using Project Aria, our initiative to accelerate research into AR glasses and live maps that we talked about last year.
Remember the mock apartment we saw earlier? Well, we've indexed every single object in it, including not only location, but also the texture, geometry, and function of each one. We fed all that information into the Project Aria glasses Ming-Fei is wearing in this next demo. And the reason is to simulate how AR glasses will ultimately be able to access data from a 3D map that will help them identify the real-world objects in the space around you and better understand your context so they can help you. What's happening here is that the glasses are calculating where Ming-Fei is in the room, locating and identifying all the nearby objects based on the index mentioned earlier, and figuring out which of those objects Ming-Fei is interested in by observing her eye movements. That contextual information, in turn, enables the system to offer proactive assistance to Ming-Fei in a variety of ways. Here, the system knows that she may want to turn on the TV, so when she clicks while looking at it, the system turns it on. Ultimately, her AR glasses will tell her what her available actions are at any time.
Hey assistant, where's my favorite mug?
We're also working on a voice interface that will let you locate any object. Here, the system is displaying the current location of the mug. In the future, it might tell her where it is using speech or text, or it might highlight the location in her glasses. Really, it's an early look at the sort of intuitive, low-friction interface that AI plus EMG input will enable in the future. This is how we'll all be interacting one day.
Thanks, Michael. That was awesome. All right, so I hope that gives you a sense of some of the technical challenges that we're working on to deliver deep and immersive experiences in the metaverse. A lot of what we've shown today isn't going to be available in the next year or two. Some of this is still a long way off. But this is some of the most exciting stuff that I've ever gotten to work on, and I'm just incredibly energized to be on this journey with all of you. And there's one more thing that I want to tell you about today. I believe the metaverse is the next chapter for the internet, and it's the next chapter for our company too. So I've been thinking a lot about what this means for our company and who we are as we embark on this journey. We're a company that focuses on connecting people. While most other tech companies focus on how people interact with technology, we focus on building technology so people can interact with each other. One of the reasons I started Facebook was that at the time you could use the internet to find almost anything. Information, news, movies, music, shopping, except for the thing that matters most of all, people. Today, we are seen as a social media company. But in our DNA, we are a company that builds technology to connect people. And the metaverse is the next frontier, just like social networking was when we got started. Facebook was born in a specific time and place, a college campus, the web. It was what we could build at the time to put people back into our experience of technology. But connecting people was always much bigger. From way earlier on, I remember sitting in middle school classes, sketching in my notebooks, ideas that I wanted to code when I got home. And even though I didn't have the skill or technology to build it yet, it was always clear that the dream was to feel present with the people we care about. Isn't that the ultimate promise of technology? To be together with anyone, to be able to teleport anywhere, and to create and experience anything? Yet here we are in 2021, and our devices are still designed around apps, not people. The experiences we're allowed to build and use are more tightly controlled than ever. And high taxes on creative new ideas are stifling. This is not the way that we are meant to use technology. The metaverse gives us an opportunity to change that if we build it well. But it's going to take all of us, creators, developers, companies of all sizes. Together, we can finally put people at the center of our technology and deliver an experience where we are present with each other. Together, we can create a more open platform with more ways to discover experiences and more interoperability between them. And together, we can unlock a massively bigger creative economy. I know the internet story isn't straightforward. Every chapter means new voices and new ideas, and yes, there will be challenges and risks and disruption of established interests. But there will also be opportunities and benefits that we can't even imagine yet, for connection,